Welcome to the channel. Today you will see class 10 NCERT chapter number 8 Introduction to Trigonometry. The trigonometry word comes from the Greek letter actually. This is Greek letter. The trigonometry we can able to divide in three ways. One, trie in the sense we know very well that is 3, and another one is what is that? Gon, that is GON. So this means is sides. Sides is the meaning. Next is metri or metron also they will call in the Greek letter. Okay, metri or metron. This means measure. So the meaning is what now? We are going to measure sides of the triangle. Tri in the sense 3 or 3 sides. Okay, right. This is the meaning. So what type of triangle we are going to use now? In this what is the trigonometry? We are going to use only right angled triangle. Only the right angle triangle only we are going to use. Okay, right angle triangle in the sense one angle should be 90 degree. That is I am taking here. So I am taking first name ABC. In the ABC, angle B is 90 degree and angle A is the theta. Theta in the sense just I am giving some name. This is also one of the Greek letter. Just I am giving name for some angle. Theta, alpha, beta, any even smaller tree also you can use, no problem. Okay, now listen carefully. That angle opposite side is called opposite side. They likewise they will call. And 90 degree opposite side is called hypotenuse. We know very well hypotenuse is the longest side actually in the triangle. Okay, hypotenuse. And rest of the side is called adjacent. They will call the adjacent side. Now this is opposite side. Theta opposite side is called opposite side. 90 degree opposite side is the hypotenuse. Rest of the side is called adjacent. Okay. Now from this we are going to find trigonometric ratios, trigonometric identities, and complementary, trigonometric table, many things. First one by one we will go. First trigonometric ratios. Okay. Now we have totally 6 function actually here. First trigonometric ratios. So right, trigonometric ratios, let's see first. We have totally 6 functions. One by one I will write. First we have the function sine. So sine, this is full name sine, but we are going to use just sin. Okay, here a sine of theta. So we need to read sine of theta. Na? Simply we will read this sine theta. Understand? Simply we will use the word sine theta. Sine theta using for what in the sense? Sine theta using for find height. This is opposite side we are giving. Na? This is height of this triangle. Okay. So the sine theta is used for finding height. Okay. Next cosine. Cosine of theta. Cosine of theta in short form we will use cos theta. Cos theta using for finding adjacent or base. Okay, and next tangent they will call actually simply tangent of theta. The tangent of theta only in simple form we will call tan theta. Tan theta is a combination of sin theta and cos theta. It means if you divide sin and cos, you will get tan theta, because tan theta is used for measure both height and base. That's what I am telling. It is combination of sin and cos. Okay. Next cotangent of theta. So this is meaning what is that? Cot. Simply we will read cot theta. This is a reciprocal. What is that? Reciprocal of tan theta. Means 1 by tan. 1 by tan theta equal to cot theta. Okay. Means what you will get? This is cos theta by sin theta. You will get actually these things. Okay. This is cotangent. Next secant. Of theta. Means what is that actually? This is also useful for finding what is that? Adjacent. Okay, this is also useful for finding adjacent. I mean what we are used for cos theta, same thing only here, because this is a reciprocal of cos theta, so that what we are using the same thing. And this one we will read secant theta. Sec theta, but you have to read secant theta. Okay, And next, what is that? Cosecant. Cosecant of theta. This is also useful for finding what I said, that height I said, opposite side means what we are used for sin theta, that is we are going to use. Okay, this is also useful for finding height, but when we read cosecant theta in short way, but you have to write like this, but the reading, what is that rotation is cosecant theta. Okay, likewise only you have to read. Now this is the sixth function we are going to use here. And the trigonometric ratios I said now, this is sixth function. So what is the ratios? How to write the ratios I will show now. Let's see the trigonometric ratios. Now we have six function I said. First one sin theta, okay, and next one cos theta, another one tan theta, okay. And here first I will give, this is very important actually, sin theta, in the sense I told you already, it is useful for finding height. So that sin theta, which is equal to opposite side divide hypotenuse. Simple, in short way I am writing opposite side divide hypotenuse. Understand? And cos, in the sense it is useful for finding adjacent I said. So adjacent side divide hypotenuse. Likewise, and tan theta, in the sense I told you already, combination of both sin and cos only, that is means it is useful for finding height and base. So that here opposite is the height and adjacent side, means if you divide this together now, the hypotenuse will cancel, remaining you will get opposite divide adjacent. If you divide this, hypotenuse cancel, opposite divide adjacent. That's what we are getting like this. Now I told you already cosecant, that is cosecant in the sense reciprocal of sin theta, means what we have here, that is only you will get hypotenuse divide opposite. Okay, and reciprocal of this only we have secant theta, means hypotenuse divide adjacent. Okay, next reciprocal of tan only we have cot theta. Totally the six function only we have adjacent divide opposite. So this six ratios you need to remember. This is very important. At least if you this three remember this now, based on this we can able to remember this also. Understand? And this is very important. Next we are going to see the trigonometric identities. The trigonometric identity also comes from this what is that right angle triangle. First of all we'll go for a Pythagoras theorem. In right angled triangle, square of the hypotenuse which is equal to sum of the square of the opposite sides. This is the Pythagoras theorem actually. Now by using that I am going to write. So the trigonometric identities we need now, we have to go for a Pythagoras theorem. A simple diagram I will draw here. This is 90 degree, A, B, C. 90 degree opposite side is hypotenuse, adjacent opposite. Simply I will write this. Now we know that in a right angle triangle, square of the hypotenuse side which is equal to sum of the square of the opposite sides. Now these things we have to take. So by Pythagoras theorem, AC square means square of the hypotenuse side which is equal to sum of the square of the other two sides. AB square plus BC square. Okay. Equation number 1. Now we have three sides in the right angle triangle. Any one side you can take, divide by these three values, then you will get three trigonometric identities. First I am going to take AC. So equation 1 divide by AC square. Then what I am getting, let's see. Listen carefully. So AC square divide AC square. Likewise AB square divide here we dividing AC square plus BC square divide AC square. Now I am dividing by AC square. So this AC square cancel. Then I am getting here 1. Here we have square is common for both numerator and denominator. I am writing here, and this is AB divide AC plus, and here also we have common square, so that I am giving commonly ones. Now listen carefully. AB in the sense, what is that? Adjacent. Okay, and AC in the sense that is hypotenuse whole square we have, and BC in the sense that is opposite side. So I'm giving AC in the sense hypotenuse whole square we have. Okay, now what is the adjacent divided hypotenuse? We know very well that is cos theta. Now only I given. And what is the opposite divided hypotenuse in the sense that is sin theta whole square. Okay, now this function we can able to write cos theta whole square or cos square theta, both are same only because that square not applicable for this theta. Okay, and sin theta whole square or sin square theta, anything is same, and this is the very important identity. Okay, now from this we can able to find another two subdivision, that is I will tell you. If we need just cos square theta alone, if we need na, send the sin square opposite, then 1 minus sin square you will get it. Understand? Or if we need only sin square in the sense, send the cos square opposite, then you will get 1 minus cos square. Like that we can able to get it 2. Suppose you want only sin theta in the sense, send the square opposite, then we will get square root of 1 minus cos square theta. Likewise here also, if you need only cos theta, send the square opposite, you will get 1 minus sin square theta. So now we are getting two subdivisions here. In same way, let's see another identity. Same equation one I'm going to use. Now I'm going to divide by AB square. Okay, what is that? Equation 1 divided by AB square. Then what we will get it, we'll see. So AC square divided AB square, which is equal to AB square divided AB square plus BC square divided AB square. Now this AB square cancel, we are getting 1, so 1 here, and this is I'm writing AC, what is that? Hypotenuse, and AB we know is adjacent. Okay, now we have square na, whole square I'm giving, plus BC in the sense we know is opposite side, AB in the sense that is adjacent side, and this everything we have square, so commonly once I'm giving whole square. Now hypotenuse divided adjacent in the sense that is we know secant theta, so we have a square, so that secant square theta I'm giving 1 plus opposite divided adjacent in the sense that is tan theta, we have a square, so that tan square theta. This is another identity we are getting. Okay, another identity. This is from this also we can able to get another two subdivisions. Suppose we need 1 alone in the sense tan square, you can bring this side, so secant square theta minus tan square theta, which is equal to 1, or else if you want only the tan theta in the sense 1, you can send opposite, then secant square theta minus 1, which is equal to tan square. If you want only tan theta, send the square opposite, then we will get square root of secant square theta minus 1. Okay, likewise here also, here nothing, that's it. And from here if you want only that secant theta, send the square opposite, then you will get square root of 1 plus tan square theta. Okay, now another one, let's go. Same equation number 1, but I'm going to divide by BC square. So BC square I'm going to divide. Now what I will get it, this everything by BC square. After the BC square cancel, remaining we are getting 1, so that this is AC in the sense we know that is hypotenuse. So hypotenuse divided BC in the sense opposite side, we have a square, so whole square, which is equal to, likewise AB in the sense adjacent, BC in the sense opposite, whole square, that plus 1. Now hypotenuse divided opposite in the sense we know cosecant, that is cosecant square theta, which is equal to adjacent divided opposite in the sense that is cot square theta plus 1. This is another one important identity. Okay, suppose if you want only the cosecant theta in the sense, from this if you want only the cosecant theta na, send the square opposite, then you will get square root of cot square plus 1, that's it. Now another two subdivisions, listen carefully. If you want only one, bring this opposite side, so cosecant square theta minus cot square theta, which is equal to 1. This is another one identity. If you want only the cot square, okay, so cot square you can keep it this side, send this one opposite side, then what I'm getting, cosecant square theta minus 1. This is another identity. Here if you want only cot theta, send the square opposite, then square root of cosecant square theta minus 1. Okay, this is the trigonometric identities. Totally 9 identity we need to prepare, and this is very important. Next we will go for a trigonometric table. Okay, before going table, let's complete trigonometric reciprocals. So we have totally 6. One by one I will write. Sin theta in the sense that is 1 by cosecant theta. You have to remember. Suppose if you want cosecant theta na opposite, like 1 by sin theta. Okay, likewise cos theta in the sense 1 by secant theta. Secant if you want na opposite 1 by cos theta. If you want tan theta in the sense, which is equal to 1 by cot theta. Cot theta if you want opposite 1 by tan theta. Here you have noted the very important thing, tan theta equal to, we know, sin theta divided cos theta. Likewise cot theta in the sense cos theta divided sin theta. This is I am giving a note. This is very important things. Okay, these 2 points. This 6 function is very important. If you remember these things, opposite of this only you will get it. Understand? Now we'll go for a trigonometric table. This is one of the important table. Even this is useful for 11th, 12th, 10th. Even if you go for college level also, it's very useful. Now I'm going to give some standard values only. First of all, what is that? 0 degree and 30 degree and 45 degree, 60 degree and 90 degree. These things only I'm going to give. Okay, now we have totally 6 function, that all the 6 I'm going to write one by one. First sin theta, next cos theta and tan theta, cot theta I'm writing down actually, and cosecant theta, next one is secant. So all the things I was written now. So one by one we'll go. Before that, so how to start, how to remember this table in easy manner I'm going to teach you. Listen carefully. This is like little like rough work. So whole number we know starts from 0, 1, 2, 3 and 4. Why I stopped up to 4 now? What is that? In a trigonometric quadrant we have 4 quadrants like that. Just remember, because I'm going to use based on that only. What it is entered a value, divide 4. In the same value just you divide. This is small tricks to remember the values. And take root for all the things which is possible to cancel. That's you can cancel 1. This is 1 by 2 which is equal to 0. Now if you take square root in the sense, what we are getting, that is the value of sin theta. Now 0 square root value 0, 1 root value 1, 4 root value 2, 1 root value 1, 2 root value nothing, so root 2 you can write, 3 root value we don't know, 4 root value 2, 1 root value 1. This is the value of sin theta. If you know this only one value, based on this we can able to write the remaining 5. Okay, let's do this. Just write reciprocally this, you will get the cos theta. Okay, now 1, here I am writing root 3 by 2 and 1 by root 2 and 1 by 2 and 0. That's it. If you divide this together, you will get a tan theta. Understand what we are doing? We are doing reciprocally, we are writing. That's it. Reciprocal means the reverse order we are following. Here we are dividing 0 by anything, 0. If you divide this together, 2 will cancel, then 1 by root 3. This 2, I mean here if you divide now, fully will cancel, you will get 1. If you divide this, 2 cancel, root 3 by 1 means root 3. If you divide this 1 by 0 means not defined. That's it. If you write the answer in a reverse way you will get the cot theta. Again not defined, and root 3 1 by root 3 0. Okay, now cosecant. Cosecant in the sense reciprocal of sin theta. This is we are writing in reverse way. Cosecant in the sense reciprocal of sin, means by 1 is there. If you reciprocal, 1 by 0. 1 by 0 not defined. Reciprocal of this 2 by 1 means 2. Reciprocal of this root 2 by 1 means root 2. Reciprocal of this 2 by root 3. Reciprocal of this 1 only. If you write this value in a reverse way, that is the secant. Write this now 1 2 by root 3 and root 2 2 not defined. That's it. This is our trigonometric table. Okay, so it's very important. Just remember this. I will show like a, what is that, through line I will show, just wait. Now we have in the table just little in a rough work, like I primed this table. This is the things. Okay, this is very important. Next we have complement, and next this is for 6 function. We have first sin theta. I'm giving sin theta in the sense we know very well, which is equal to cos of 90 degree minus theta, and reverse of this. If you want cos theta, means cos theta, what is that, sine of 90 minus theta. Okay, and tan theta if you need, which is equal to cot of 90 degree minus theta. Likewise, if you want cot, reverse of that, tan 90 degree minus theta. And last secant theta if you want, cosecant of 90 degree minus theta, and likewise cosecant theta if you want, this is secant of 90 minus theta. Okay, so if you remember this 3, it's very easy to go. Okay, this 3 just you remember. Sine in the sense cos, tan, cot, secant, cosecant. This pair, like a pair you can remember, then you will get this 3. That's why I'm writing like this form. Okay, these things if you know very well now, the trigonometry chapter is very easy, not only in 10th, 9th, 10th, 11th, 12th, college, everywhere. This is very useful. Okay, thank you my dear. Thanks for watching this video. Subscribe for getting more videos and press the bell icon for getting notification.